Welcome to lecture 39, templates and generics. So, in the last lecture we had seen several generic methods in Java, right. So, on the continuation, right. So, we will see another method which will be calculating GCD, the greatest common divisor of two integers, right. So, let us consider it is going to support both integer and long, right. So, now we have the class math utilities, name of the class math utils, and T is extending number, right, interface, and we have a method GCD whose return type is T, alright. So, A is one number you are going to give. So, let us say whatever be the number and the corresponding is T, suppose it is an integer, T is integer, suppose it is long, T is long, alright. So, now you are converting into long, alright. So, here number 1 is long and number 2 is long. So, you are converting into long, A dot long value, alright. Suppose you are giving integer, it will be converted into long, B dot long value converted into long. So, now things are simple. If while num2 not equal to 0, right. So, you are passing, let us say I want to find GCD of 10 comma 20, alright. So, GCD of 10 comma 20, right. So, you are seeing this is number 1, this is number 2, correct. So, when it is not equal to 0, right. So, number 2 you are assigning to temp, correct, and then you are finding out number 1 mod number 2, correct. So, number 1 mod number 2, and then you are assigning whatever be the number you are getting, you are assigning to number 2, and temp you are assigning number 1. So, again you are checking whether number 2 correct. So, number 2 is not equal to 0. Maybe we work it out GCD of 10 and 20, what will happen, right. So, number 2 20 is not 0, true. So, while loop is going inside. So, now temp is nothing but 20, right. What will be your number 2? Number 2 will be number 1 mod 20, right, 10 mod 20, 10 mod 20 is 10. So, number 2 is becoming 10 and number 1 is now becoming temp, that means 20. I am just swapping kind of initially, right. So, now number 2 is 10 which is not 0, right, number 2 is 10 which is not 0. So, temp equal to number 2, right. So, temp is equal to number 2. So, what will happen? Temp is equal to 10, second iteration, and number 2 will become number 1 mod 10. So, what is 20 mod 10, correct. So, number 1 is here 20 mod 10. What is 20 mod 10? 0, right. 20 mod 10 is 0. 2 into 10 is 20, remainder 0. So, remainder 0, number 2 is 0 now. And what is your number 1? 10, right. So, now while loop you are coming, while number 2 not equal to 0, false, right. Reason is number 2 is already became 0, right, and then you are coming out printing the long value of number 1, number 1 is 10. So, that means GCD of 10 and 20 is 10, greatest common divisor of 10 and 20 is 10, alright. We have taken a simple example. This is how the loop is working. And now, what we can do, we will go to the main program, correct. So, in the main you have integer, right, integer A equal to 56 and B equal to 98, right, integer A is equal to 56, B equal to 98, and long x, this is a long value 1, 2, 3, 4, 5, 6 up to 9 and 9, 8, 7 up to 1, L stands for the long value. So, now I am finding GCD of 56 and 98, right. So, GCD of A, B, I am passing 56 and 98, right. So, this is nothing but integer now, your T is integer, capital T is becoming integer, and A and B values are nothing but 56 and 98. So, when you are passing this, now this integer value is becoming long. Number 1 is that A dot long value is converting, it is a function, it is a method. A is invoking the method, inbuilt method long value, that is under number, correct, and another one is B long value. So, both are becoming long, 56 and 98 is now long, and then you are doing the same algorithm what I have explained for 10 and 20. So, then it will return the GCD, right. So, similarly, it is a big number, already it is long. So, now I mean even the conversion number 1 and number 2 will become long, and more importantly T is what now? Long, right. So, T is long. So, here you have long. So, T is long, right, in fact capital L, that is what we have written here, alright. So, it is a long number, number will take care. So, capital L, alright. So, this number will take care. So, you are converting into the usual long, alright, and then you are running the algorithm for this big number x and y. So, we know that that will give you the GCD. So, that will be returned, right. So, when I am calling this, that will be returned. So, we will see the code, how this is working, we will see the code. So, I will go to the Java console and you can see here, right. So, the long value, so when you are passing 56 and 98, the GCD of 56 and 98 is 14, right, and GCD of 1, 2, 3, 4, 5, 6, 7, 8, 9 and 9, 8, 7, 6, 5, 4, 3, 2, 1 is 9. Okay. So, this is how we can calculate, and more importantly the concept point of view. So, one place it is becoming integer, t becomes integer, in another case t is becoming long, right. So, this is how the generic method is working. Now, we had seen several examples, right. I hope by now you are familiar with, right, the generics. We will see one more program, right. So, interestingly we are going to see many mathematical programs. So, here you are going to find out the dot product of two numerical vectors, right. So, this generic method is for the calculation of the dot product of two numerical vectors. So, I have vector math class and t is extending the number, right. So, here you have dot product is the name of the method, return type is double, right, return type is double. You have array of t, right, array of t, and that you call it as vector A, and array of t you call it as vector B. So, two vectors. Let us see what are the arrays, it is an integer array or double array, those things we will see, right. So, now both the length should be same. So, when I am doing the dot product, suppose I have 1, 2, 3, 4, another one is 5, 6, 7, 8, right. What is the dot product? 1 into 5, right, 1 into 5 is 5 plus 2 into 6 is 12. So, let us say these are tuples in the vector, right. So, 2 into 6 is 12 plus 3 into 7 21 and then 4 into 8 32. So, add all this, right. So, this you call it as dot product, right. So, suppose the length is not equal, assume that one length is 1, 2, 3, another one is 5, 6, 7, 8, you can't do, right. So, that is what you are checking. If vector A dot length is not equal to vector B dot length, right, it is throwing the exception, right, it is throwing the exception, it is an inbuilt exception, illegal argument exception. So, vectors must be of the same length will be printed. Assume that you are giving the wrong input, right, one is 1, 2, 3, another one is 5, 6, 7, 8, right, one is having only 3 components, another is 4 components. So, they are not, length is not same, so that will throw an error. Otherwise, right, suppose, right, if it is coming after if means in the else part kind of, right, you do not need to put else, it is understood. That means vector A dot length is equal to vector B dot length, right. Now, sum is equal to 0.0, initially we are initializing, and for int I is equal to 0, I less than vector A dot length, any one length, now both are equal, I plus plus, right. So, sum is equal to whatever I said, initially sum is 0, right, sum is 0. So, vector A of I, right, dot double value, right. So, that it means it is converting into double value, right, the number under number it will be converting into double value, right. For example, here it is nothing but 1 into, it is 1.0, right, it is nothing but 1.0, even though you are giving 1, that is what this method will do. So, meaning is 1.0 is getting multiplied with 5.0, vector Bi dot double value, right. So, first is sum, that means sum is becoming 5.0 first. When you are doing this, 0 plus this is 5.0. Next, when I is becoming 1, this component will be multiplied, that is what you are doing, and then I become 2, 3 into 7, I become 4, 4 into 8. I have just taken an example and then it will return sum, correct. So, now we will see in the main what are all the vectors we are using, okay. So, now I hope you understood, right, return sum, that means this particular method, correct, the name of the method is dot product, right, this is returning, all right, this is returning sum. So, now in the same class, it is a driver class, in fact you have main method. So, main method you have two vectors, one vector A which is integer that contains 1, 2, 3, another one is vector B which is also integer array, right, 4, 5, 6, fine, and then you have two double arrays, vector C and vector D, okay. So, we have 4 arrays. So, 2 are integer arrays, vector A and vector B, and vector C and vector D are nothing but two double array. So, now let us call the function, right, let us call the method. So, system.out.println I am printing dot product int vectors, right. So, the dot product you are calling by passing vector A and vector B, right. So, now this T is becoming what? Integer, right. So, the T is becoming integer. So, when I put the notation like this, alright, when I put the notation like this, so it is nothing but an integer array, T is becoming integer. So, integer array. So, what you are doing? You are passing vector A, alright. So, here local variable you have vector A and you are passing vector B, and here local variable is also vector B, right. So, vector A and vector B you are passing. So, now both are same length. So, this is ruled out and it is coming over here as usual, right. So, what it will do? 1 into 4, in fact 4.0, right, you are converting, plus 2 into 5, 10.0, right, then 3 into 6, 18.0. So, 18 plus 10, 28, 28 plus 4, 32.0 is your first output, right. So, dot product int vectors is 32, right. Next one is you are passing dot product, you are passing vector C and vector D, right. So, when you are passing vector C and vector D, so what will happen? It is copying, vector C will be copied into local variable vector A of this method and vector D will be copied into vector B, and then again the product, right, this will be executed, both are same length. So, this will be executed 1.1 into 4.4 plus 2.2 into 5.5 plus 3.3 into 6.6, alright. So, let us see, because you have to, you need some calculation. So, that particular output you will get, right. So, let us consider in the program, let us go to the program and you will see here you have the same, right. So, first one I have written 32.0, right, this is what I wrote because it is easier to calculate for me. Next one is a numerical, alright, 1.1 into 4.4 plus 2.2 into 5.5 plus 3.3 into 6.6, right. You verify, you cross verify this, you should get 38.72, okay. So, now the important thing is, so here you have write the method, you can see T, one time it is becoming integer, another time it is becoming double. So, we had seen several programs, right, with respect to Java generics, right. So, we had seen methods as well as classes, right. So, now we have the advanced type called bounded types, right. What do you mean by bounded types in Java generics? So, bounded types, this allow us to restrict the type parameter to a specific superclass or interface, right. So, we are moving from the subclass to superclass or subclass to interface, alright. So, when we are using this, we have used several times, right. So, this particular syntax is saying that, so we are restricted to be a type class name, right, particular class name or any of its subclasses, right. Whereas, the bounded types, right. So, when I am talking about the bounded types, which is supporting both upper bounds and multiple bounds. Upper bounds in the sense extends, T extends class name, right. So, that means we are going to a type parameter to a specific superclass or interface, right, and multiple bounds. So, multiple bound means it is implementing interfaces, right. So, that means bounded types which is supporting both upper bounds and the multiple bounds. So, we will see an example, right. So, here we have one example, T extends number. Let us assume we are adding, right, two entities, A is under T and B is under T. So, T may be anything, right, this we know, if it is a integer or it may be a double, it may be a float. So, we are converting into double and we are adding both, alright. So, that is what we are doing over here. So, let us see, right, some more example, alright. So, here this is a simple example, correct. So, the syntax T extends number. So, this is restricting T to be of type that particular class name, the class name is nothing but add, alright, or it may be of one of its subclass, any of its subclass, correct. So, let us see how, I mean, this bounded types is being supported, right, both extends and implements, right. So, when I am writing T extends number, right, so you are restricted to T which is extending to number, correct. So, that means I can use the superclass or the interface of the number, right. So, that is the meaning. So, let us go slightly advanced wildcard types in Java generics, right. So, wildcard we can use the question mark, more flexible generic method, right, or we can have the class definition by allowing an unknown type to be specified with the question mark, right. So far we have not seen question mark. So, you can see in this particular example the question mark extends number, right. So, it is of any type, right, unbounded wildcard question mark, right, and when I write question mark extends number which is nothing but upper bound. Now, I am talking about the upper bound, right, extends t which is nothing but upper bound wildcard or any subtype of the t, right. So, assume that, let us assume when we are using this question mark, right. So, it is as such, previously we talked about t, right, previously we talked about t, right. So, when I have this, we are writing this extends number, right, the question mark extends number. So, here number is nothing but t, right, assume that the number is nothing but t, that is what we are telling, alright. So, that means this can be any subtype of t, right, that means any subtype of number, and we call this as a upper bound wildcard. And suppose you are writing, right, one more syntax question mark super t, right. So, that is any super type of t and which is called lower bounded wildcard. So, in this example this is upper bounded wildcard. This is an example of the upper bounded wildcard. So, question mark extends number. So, question mark extends t, t is a number now, right, which is nothing but upper bounded wildcard, any subset of the number. Okay. So, similarly you can use this syntax question mark super t, right. So, let us see this particular example. The same syntax I am using, right. You have public class with the wildcard example, this is a class, right. Here you have a void print list, your question mark extends number, right, question mark extends number, question mark extends t means upper bound wildcard any subset of t, t is a number, right, that is the meaning. So, it is extending this and then your list, alright, your list, let us say name of the array, correct, for number n and list. So, now n and list is going to point out the same identity hash map, right, and then you are printing n. So, that means we are going to take our list, correct. So, on one blank space, correct. So, our function is over here, your method is over here, start from here to here. Now, this is a driver class, wildcard example is a driver class, you have void main, right, you have int list, this is an object. So, this object under list, right. So, this object is under list of integer, right. So, this already I have imported Java utility import list. So, list of integer you are having one object int list and the int list is nothing but 1, 2, 3, 4, alright. So, what we are doing now, your list will be nothing but list of integer, your list is nothing but list of integer, list you are extending number. So, list will become the list of integers, wildcard, this is a wildcard type, right, and rest of them are similar. Your n and list is now pointing to the base address or you call it as identity hash map and 1, 2, 3, 4 will be printed with this, right, syntax system.out.println, it is printing 1, 2, 3, 4, alright, and then you have double list, another object called double list under list of double, alright. So, now you can understand that question mark, right, what it is showing, question mark extends number. In one case I am using integer, another case is I am using double wildcard type, okay. So, and then I have a list of 1.1, 2.2 and 3.3 double list. So, now I am calling the function. So, integer list will be printed and the print list method I am calling by passing int list. So, when I am passing this int list, right, now list is nothing but the integer list 1, 2, 3, 4, right. So, now I am mapping to n. So, base address or you call it as identity hash map, n and list are same, right, and then you are printing n, I will print 1, 2, 3, 4, the first output will be 1, 2, 3, 4. Then I am again calling print list by passing double list, right, by passing double list. So, double list here you have, right. So, here you have double list, correct, passing double list, that means I am passing 1.1, 2.2 and 3.3, correct. So, list is now becoming double list. That means both identity hash map are same, list and double list. And here in line number 5, correct, in line number 5. So, line number 5 you have number n colon list. So, that means identity hash map of n list and double list all are same, right. So, what is n now? 1.1 second case, and I am calling this 1.1, 2.2 and 3.3, correct. Anyway, we are asking to print here itself, yes. So, we should get these two output, one output is 1, 2, 3, 4, another output is 1.1, 2.2 and 3.3. Let us run the code, right. This is what we expected, 1, 2, 3, 4, yes, we are right, and another one is 1.1, 2.2 and 3.3. So, you can do some manipulations. For example, at dot product we had seen, right. So, like this, I mean you can work it out with the help of the wild type, right, wildcard type, alright. So, this is what we have done that, right. So, it is still enforcing the type safety, right, that is very important. In one case we have used integer and another one is double, right. So, the data type safety is still there. So, these are all the comparisons. In C++ we have templates, right, and in the case of Java you call it as generics. So, templates are processed at during the compile time, right. So, which is creating separate instances for all the types, right. Suppose you are using integer or double or character, all right. So, you have separate instances. So, we can able to do that, whether it is a class or method, you can do that, and we had seen many flexibility. In fact, we had seen several cases, in particular serializability and all we worked out, all right. Only difficulty is it will create the larger binaries, right. So, otherwise it is offering lot of flexibility, and problem with C++ template is a lack of type safety, right. So, errors can occur. So, when you are converting double to integer, integer to double, right, or the multiple classes that you are using or multiple data types that you are using, right. I mean to say multiple templates you are using. So, in that case, so errors may be detected and it will be instantiate rather than the declaration, right. So, these are all about C++ template, whereas in the case of Java generics, right. So, this is also enforced at compile time, but I mean that will be eased out when you are going in the runtime, right. So, that will be taken care. So, compile time we may have a problem, but it will be eased out when you are at the runtime, and it is also ensuring the type safety, and it is catching the exception or type errors during compile time. So, here it is less flexible than C++ template, right, because you do not have any template specialization, right. So, there are some advantages in C++ we had seen, right, the multiple, right, multiple classes or multiple templates, right. So, these are all some of the advantages we had seen in C++, whereas that is not available in Java. So, templates in C++, so they are powerful for code reuse, right, but lack in runtime type safety, right, and it is more flexible. And in the case of generics in Java, so this is ensuring the type safety during compilation time, right, but it is lacking some flexibility due to type erasure. So, but both the cases, right, both the cases, that means generics or templates, so we have enjoyed that reusability of the code, right. So, you can write, let us say, template class or template methods. So, whatever be the type, whatever be the data type, so we are able to reuse it, right, and then both techniques are very efficient, right, and we have used, right, multiple types in both the cases, whether it is a templates in C++ or generics in Java. So, yeah, each with unique trade offs. So, that means they have advantages as well as disadvantages when we are comparing with both these, right. So, now we had seen generics in Java, right. So, what we can do, we can also talk about generics in Python, right. So, first time we are learning Python, right. This is 39th lecture I believe, all right. So, first time we are talking about Python. So, as you know, it is an interpreter, right. So, it is an interpreted language, which is a high level language, which is known for the readability and versatility, all right. So, mainly people are using for machine learning, deep learning, data science or the web development, the Python is being used. So, here we have taken Python because when we are talking about generics, right. So, we will see the very basic codes as well, right, before learning or before I am talking about generics. We will run some basic code and then we will talk about generics. So, here it is, the theory is saying it is dynamically typed, alright. So, the types, I mean to say the data types, right. So, they are inferred at runtime rather than specified explicitly. So, suppose you are using a equal to 5, alright. So, like int a equal to 5, let us say in C++ or Java, it will be automatically understood. That is what this particular line is saying, right. So, let us start with Python 3.5 and then type hints and annotations were introduced to improve type clarity and enable generic programming. So, alright. So, before concluding this lecture, so maybe we can see the small code in Python, right. I will start with the addition of two numbers. So, let us right, this is a Python simple, right. We always start with the addition of two numbers or hello world. So, define add of a comma b, alright, it is a function and then return a plus b, alright. So, define add of a comma b 1 colon return a plus b. So, now in the result you are calling this function, right, add 3 comma 4, you are passing 3 for a and passing 4 for b. So, 3 plus 4 I have to get 7, right. So, this one example we will do it in today's class and then I will wind up. Yeah. So, we will run the code, right. Python interpreter you are seeing. So, here you go, the same program what I have explained, correct. So, when you look at the result, add a comma b, return a plus b, you are calling the function and putting in result and we are seeing what is result, right. You can see the output is 7. So, we are passing 3 and 4 and we are getting the output 7. Okay. So, like few basics we will see. So, here we have defined the function, right. Inside the function you are writing the algorithm, addition of two numbers, return a plus b and then you are calling this, the function call, you call it as a function call, alright. So, this is the basic Python I am introducing. We will see some basic code and then I will talk about generics in the next class. So, with this I am concluding today's lecture. Thank you all.